Good morning. We are going to be working on lesson 1.5 today. And there are a few prep skills that would be good for you to have under your belt before we get started. I'll go ahead and share my screen here so you can see those prep skills. So it would be good to maybe go through some of these in case you need some refreshers. So on page 75 here. So converting fractions into percent form. A fraction is always a part out of a whole multiplied by 100, or moving your decimal places to right to get it into the percent form. Remember, percent form is just a symbolic form representing per 100. And then we're going to use this in our percent increasing percent decrease formula, which we also use in 1.1. Finding the area of a rectangle is your length times your width. So let's just write that formula down here. Area is length times width. We're going to use that today. So the area of a rectangle with length 15 and width 3 can be calculated by one of two ways. So we could convert the 15 inches to 1.25 feet and get an area of 3.75 square feet. Area is always going to be units times units, so you're going to have square units. Or we could have converted the 3 feet into inches, into 36 inches, and then we could have ended up multiplying and had square inches. So there's going to be some converting from lesson 1.4 in this lesson as well. Converting units, which we just did in lesson 1.4. And then here's some other questions that you could work on. Remember, the answers to the prep skills questions are at the back of the lesson. Okay. So it says, when you sit with a nice girl for 2 hours and you think it's only a minute, but when you sit on a hot stove for a minute, you think it's 2 hours. That's relativity, says Albert Einstein. It's so true, right? There's times in your life where it seems like time flies by in an instant, and then there's other times when time seems to go so slow. So in a nutshell, Einstein's theory of relativity says that even the passage of time is not an absolute, but rather is relative to your frame of reference. In this lesson, we'll study appropriate ways to compare numbers, focusing on the importance of relativity. Consider these two scenarios. One scenario is I owe you $20 and I give you 10. Will that work for you? Not for me. You win 5 million in a lottery, but you only get paid $4,999,990. Would that ruin your day? I'd want to know where my extra $10 was, but probably not ruin my day. You're out $10 either way, but clearly that's a much bigger deal when the amount owed is 20. If that makes sense to you, then you have an instinctive understanding of the concept of relative change. So how does Einstein's quote about relativity connect to the examples of being shorted $10? And how cool is Einstein's hair? So if I only have $20 to my name and I lend it to someone and they only pay me back 10, I only make back 10, half of my money, which is a big deal in everyday life. But if I won 5 million and they didn't pay me $10 of it, it probably wouldn't even be a big deal. Most of us wouldn't even notice. So when asked to compare the sizes of two numbers, most people think of subtraction. But the example above shows that this isn't necessarily the best choice. The change between the two quantities is found by simply subtracting the new value from the old. This is sometimes referred to as actual change. And the absolute difference. Okay, so here's some ways that you can represent that. In both scenarios, in the opening paragraph, the change is what was owed and what was paid is $10, which leads us to conclude the significance of that $10 is the same in each case. But it doesn't seem clear that the $10 shortfall is more significant when the total amount is owed is 20. That's where the relative change comes in. The relative change between two quantities means the change is a fraction of the original value. So this is basically the same formula back in lesson 1.1 where we did percent increase and decrease. You can either look at these in two different ways. You can either look at it as strictly right here, the change over the original value, or you can look at it as the new minus the original over the original. Okay, that's the relative change. So if they only give you the difference, they've already calculated this change. You're going to use this formula here. If you have the new and the original, then you're going to have to calculate that change yourself and use this one. Symbolically in algebra class, they might show you this formula down here below. Okay, page 78. So if we look at our first scenario, I now have $10 because that's what they paid me. My original was 20 divided by my 20. So I have negative 10 over 20, which is a negative 1/2 or negative 50%. That means I'm down 50% from what I originally had. Find the relative change if you win 5 million and get paid 4,999,990, right as a fraction, not as a decimal. So this is what I now have. Out of the 5 million that I was supposed to have. Is the negative $10 out of the 5 million. That's definitely a smaller percentage than negative 50%. Now it says, compare the relative change for the two scenarios in the opening paragraph from this lesson. Does this match your intuition about the scenarios? So it says, right as a fraction, not as a decimal. Yes. The relative change is much bigger when you have a smaller original amount. Right? Up here, we started with 20, so losing 10 was a bigger relative change. They didn't ask us to, but let's turn this one here into a percent so we can do a comparison. This comes out to be a -2 e -6. This gives us some practice on our scientific notation. So that means we have to move our decimal 6 places to the left, starting right here. So that means I'm going to have a negative and then 5 zeros. And then as a percent form, we move our decimal to the right 2. So that's really negative 0.0002%. So definitely much smaller than this 50% up here. Let's say your instructor tells you that you're going to get an additional 2 points on a recent test or quiz. Describe when this would be great news and when it wouldn't be very helpful much. So come up with an example there. Love to see what you say. Thinking about it's a bigger relative change when you have a smaller original amount. So for questions 4 and 5, write a sentence that describes in your own words what exactly the given statement means. For example, when we found the 20 owed, but you were only paid 10 was a negative 1/2. So the relative change in my budget was 7% compared to last year. Okay, so I'm going to write a sentence about this. My budget increased by 7% from last year. Okay. The relative change in enrollment this year compared to last year at my college was a negative 3.5%. So that means it went down. The enrollment at my college decreased. So I'm using decrease to describe the negative by 3.5%. last year. For questions 6 and 7, write a statement using the term relative change or percent change to describe the information provided. So this here is the opposite of what we did in questions 4 and 5. Apple's profit in 2016 was 14.4% lower than it was in 2015. So the relative change in Apple's profit from 2015 to 2016 was negative 14.4% because it was lower. The value of my retirement fund was 5.5% more at the end of this year than it was at the end of last year. Okay, the more. So the relative change in my retirement account is 5.5%. So if you want some interesting reading, look up baseline budgeting. Currently, the federal budget has an automatic annual increase of 7% to many programs. But that means they should have an automatic, they need to have an increase, right, of much more than 7% overall in what they're bringing in from all of us to be able to pay for those extra expenditures. Suppose that 435 million is spent for improvements to interstate highways for 2019. If the automatic increase of 7% applies to this budget, how much is expected for that program in 2020? So it's an increase. So that means 435 million times 0.07. So 435 times 0.07 means that there should be an increase of 30.45 million. And we have to write that as an increase. So that means we have to add it to the 435 million. Is 465.45 million. Okay, so that's our increase, and when we add it, this is our new budget. So comparing actual and relative change. Here's a great example for you to kind of go through if you need to. A news article reports that this program has been cut by 5.4%. Does this match what we found in the solved example? So in the solved example, so our solved example says, I guess we need to go through that, right? Suppose that only 440 million is budgeted for interstate highway improvements, not the expected amount that you found in question 8. Find the actual change and the relative change in the amount spent from 2019 to the 440 in 2020. So we're going to take 440 million, subtract the 435, and that means we spent 5 million more. The relative change means that we're going to take the change, which is 5 million, out of the original 435 million. And so our increase was 0.0115, which is really an increase of 1.15%, which of course is much less than 11% it was supposed to be. Since the new amount is larger than the original, the change and relative change are both positive. The actual change of 5 million and relative change of 1.15% mean that the amount budgeted was $5 million more than the amount spent. So it said the news article reports that this program has been cut by 5.4%. Does this match what we found? No. It wasn't cut by 5.4%. It just wasn't increased by the full 7, right? It was only increased by 1.15%. Write a sentence or two describing the 5.4% cut and what is misleading about it. Okay. So the 5.4% cut makes it sound, right, as if less money was spent in 2020, but that is not true. They still spent more money than 2019. It just wasn't a full 7% increase, but they're saying, oh, we had a 5.4% cut. Because this is 6.55, and they said there was going to be a 7% or around 6.5% increase. So that is not true. And that's the end to part 1 of lesson 1.5.